Hello. So today we will talk about DMA and why do we need it. So this is why we need it. Right now, from the last video, we had the serial data, coming, and it was coming pretty on time. And if you notice, this message is coming in every 1 second, which matches with our delay wait time. And another way we can know for sure that we are coming in every 1 second is adding a loop counter here and incrementing it and debugging this project. Not the best way to know, but at least for this application, let me add this to a private variable somewhere here, and I will initialize it as 0. So now we should be able to monitor this in a debugger. So to debug it, you have to, let me build it, make sure everything builds, no error. Yep. So now we are going to debug the project. All right, now we are in the main loop. And before we go any further, let me put this expression as monitoring. Then we can continue our debug. So if you look at this value, you can see that it's pretty much incrementing every single second. So every second, 1, 2, 3, 4. So that all looks good. So what if you need to send a large amount of data through your serial port? So for example, let's say that we have a large amount of data. Let's call our data size 10,000. Okay, so that's our data size. Now for our data, we want to add the size of this buffer as 10,000, and now we want to add data to this data. Add files to this data. So let's initialize it after everything is initialized. So let's add it here. So for that, our data size, so we are adding that much data to the buffer. Okay, so our data, then each index of the data is going to be adding 1, 2, 5, 6. All right, so now our data is going to be super big, right? And it will be sent via the serial port, and the data will be different from what we have here. So let's debug this. This will be a simple way to show you how slow our CPU will spend trying to send data via here, and delay or basically dead blocking event for our application. So now we are in this hot. So let's go ahead and monitor. So we'll monitor this and see how often it does increment. Oh, it already started. So you see 4, 5, 6. So it's really struggling. That's because we are spending a lot of time trying to send our serial data which is here. We're spending a lot of time trying to send all this data through the serial port, and hence dead or blocking our CPU from running for a few seconds or microseconds, right? So how do we solve this? How do we make sure we still send our large data via serial and not block our CPU? That's where DMA comes in. So how do we solve this? So let's go ahead and configure the DMA with the help of the .ioc. And now let's go to our connectivity and let's go to our UART. So we want to enable this IOC, enable the interrupt. Then in our DMA NVIC settings, enable the interrupt. Then in our DMA settings, we want to add DMA, and we want to add it on the sending of data, transmitting of data. That's where we need help with DMA. And these settings are fine. Also, we have this is fine to leave as default. Then the mode, we can do circular or normal. For this, we are doing normal for now, and that looks good. One thing we might be able to do is try to blink this GPIO. So if you remember, we put the GPIO in pin out mode in order to blink it. And after we do all of this, I believe that's all we have to change. Then we can generate the code one more time. All right, so now we can open the project. Oh, okay. So now we can go ahead and set this up. Oh, I'm in the wrong place. Main window, and we can go ahead and change this to DMA transit, and we can select our data is fine. Then we can do size of data, and this function does not require a time delay. I don't know if you caught that. So if we go to this function, it does expect the serial object, the data that we are passing, a pointer to the data that we are passing, and the size, and that's all. So that's all it expects. So if we go back to our main.c, now we are sending this data, we're sending it via DMA. Notice that our setup code now includes a DMA object for our serial port, but we are not using it. We are just going to just send this function via DMA. What else should we do? We can probably run this code as is, and we should still be able to get the effect that we need. But one thing that might be a good thing to do is to track when the transmitter or when the transmission is finished. So for that, let's go ahead and add a volatile okay, and let's put a counter for the DMA when it's done. In loop DMA counter, And if that's what we also want, we should also track the handler. So in order to get the handler, we need, let's go to this DMA. We need the callback function. This function, that's what we want. So we will override this function and add it to our main. So we have a prototype function, so we can add it on our user code. So whatever code you don't add between these comments, when you hit generate code in MX, it will disappear. So in our function, we can do our complete I did not include it here. So let's do tx complete. And we can do is equals to 1. Okay, so now actually let's also increment this. That's a loop DMA, Ctrl C. Let's increment this. Okay, so ideally we should notice that the callback takes more than a second to increment, while our loop is unaffected because our DMA is handling this serial port sending in the background, so it's unaffected. If you're coming from a C# background, just think of this as an async task that runs in the thread while the other function continues to run. So it will hand it off to a thread to run in the background, and it doesn't block your GUI or your UI. So that's a good way to think of it if you're coming from a C# development background. So let's go ahead and build, and we are having an error. Let's see, we have issue with this callback. Okay, all right, let's go back there. What did I do wrong there? All right, there, void. Here we go. Let's build. All right, so now we are good. So let's go ahead and debug. And remember, we want to track this loop DMA counter as well. So that's why we are doing a debug. That's fine. Loop DMA counter. Okay. That looks good. All right, let's go ahead and continue. All right. So if you notice, our loop counter is incrementing every second. 6, 7, 8, 9, 10, 11, 12. And our loop DMA counter is also keeping at pace. So another way to check let's go ahead and speed up our main loop. Let's put a 500 because it looks like it's roughly taking the DMA 1 second to send this data. Hence, we are we are in the same pace as the loop essentially. So, but if we increment the amount of time we run this loop, I think that should show what I'm trying to show here, meaning our loop counter will be ahead of the DMA counter. All right, so that's good here. Live preview, good. Okay, let's continue. All right, so our loop counter is literally going that's definitely more than less than a second. That's roughly 500 milliseconds, right? So and this is almost double. So it's the DMA is still taking the amount of time because this is a big data, so it's taking a amount of time to load it. You know what, it seems like we did something to make this work. So another way that we can make this work is increasing this data, adding another 0 and putting this back to 1 second, just so hopefully the amount of data here, 100,000 is enough to take more than a second to send over the DMA. It just felt like we made it work, or we forced it to work, but I just want to show that the DMA is actually working. All right, we are here in the main loop. We'll go to the live view and we can go ahead and hit continue. All right, so our loop counter is going fine. Remember, every second is going, but our DMA is, it's running in the background trying to catch up, just because of the amount of data it's trying to send. So it's really struggling. So that's pretty much it. We are able to hand off our heavy data transmission via serial to DMA, and we are not blocking our CPU from processing or running our task. So I will talk to you later. If this was helpful, go ahead and subscribe, and see you soon. Bye bye.